So Numpy is also a data structure, okay, like a list, tuple. Difference is you can store two-dimensional data here. So when we did list and tuple, it was only a one-dimensional variable, okay? But now you're talking about NumPy, where you can store two-dimensional. So, in a way, it is used to handle your matrices kind of structure. Okay. So let's say you say import NumPy as NP. Okay. Now you have to do pip install. You have to install it. Okay. So you may not have it. You have to go to terminal. Okay. And then here you have to say pip install NumPy. Okay. So install NumPy package at the terminal. So this is how you will install. You will say pip install NumPy. Okay. And this is how you import. And let's say you have data X and you create range of values. Okay. So range 16 will create values from where to where? Purandani. Range 16 will create values, or it will generate values from
0 to 15.
0 to 15, correct. So it will generate values from 0 to 15 and you will have 16 values. Okay. So this is just one dimensional. Now
Sorry, I
I
was
will.
on. I was talking on mute. Sorry.
Oh, no problem. Now we will reshape it. Okay. So I'm going to say x equal to NumPy has a function called reshape. So this will take the one dimension. So range will generate one dimensional values, right? So this will take that one dimensional value and reshape into the format that you want to reshape into. So I'll say reshape will take x, and then you say reshape into 4, 4. So now this is not 0 to 15 like list or tuple. This is 0 to 15, okay, in matrix format, row and column format, two-dimensional format. Okay, and if you want to see it, you simply say print x. And when you go and run it, see, this is the matrix, right? Where is
It
it?
just speaks in the matrix format.
Correct. Right? What you must have done in your maths class in high school, or yeah, in high school, right? So this is your matrix format. The next thing is, how do you, so this is how you generate. How do you generate, let's say, list into matrix format? So we can also convert a list into matrix format. So you might have a list called, let's say, L1 equal to, now let's say I want to create 3 rows. So if you say 3 rows, the entire thing has to be a list, and it is a list of list basically. So you have a list which is again composed of various lists, right? So each of this list, inner list, will become a row. So when I create a list like this, that means I'm talking about a matrix or a NumPy with 3 rows of data. Columns we don't know because we have not added the value. Now, if I add, let's say 5, 4, 2, 3, that means I'm talking about 4 columns now. I'm talking about 4 columns now. Okay. So here also I need to add 4 columns, and here also I have to add 4 columns. So let's add some values here. 3, 8, 12, 6. Okay. Here I'm going to say 4, 7, 9, 2. So we just now created, okay, a, uh, a list of lists. It's just a list of lists. Now, how do we convert this into, say, NumPy format? So we have a function called as, I'll call it as the mat1 equal to numpy.array. So we have a function called as array, and this array will take your L1 and convert into matrix format. So if you have one-dimensional data, you can use reshape. Sorry. And you have a list of list, you can use array to convert into a matrix. Okay. So now I can say print mat1. Okay. So see, so this is your first row, 5, 4, 2, 3, 3, 8, 12, 6, 4, 7, 9, 12 becomes your third row. You can add one more list if you want to add fourth row as well, and fifth row, and so on. Okay. Okay. You can also generate matrix. Let's say I call mat0. You have something called as np.zeros. When you say 0, okay, and you give size, let's say 3, 3, this will generate a matrix of dimension 3 by 3, okay, and all values will be 0 here. So I can say print mat zeros, and when you run it, you get all zeros. You see, it is 0 dot 0 dot, indicating that, it is it has taken float value, decimal value, 0.0. Now, if you want it to be integer, you can say d type equal to int. Now see, it became integer value. So by default, it was float, it became integer. Okay. So this is how you can use a matrix with zeros. Then we need to talk about how to access the values from NumPy. Okay, so indexing. We have done indexing in lists, we have done indexing in sets, dictionary, right? String. Almost same concept, okay, exists here also. So indexing, you use square bracket 0.1. You start from 0, go all the way up to that value. Okay. But since here you have row and column both, right? So you have to indicate both row and column. Now, if you indicate row and don't indicate column, that means you want all the columns. If you indicate columns but not row, it means you want all the columns. And if you want specific values, then you have to indicate both row and column. Okay. First, we mentioned row, followed by comma, and then column. So let's see an example here. Let's take this one, okay? 4 by 4, which is our x, and I want 5, 6, 9, 10, let's say 5, 6, 9, 10. So I'll say print, I'll say x, right? Because I want data from x. I'll give square bracket because I want subset of x. This is how you give indexing, right? Now, something, comma, something, right? Row, comma, column. Now, what is something in the row? So 5 is row 2. That means 1, right? We write first as 0, 2 as 1, right? So it is 1. So from 1, okay, we want 10 also, right? So we want 1 and 2, row 1 and 2. So 1 colon, okay, instead of 2, we'll see 3 because ending is always 1 more than what we need. So we need 2, okay? So we need 2, okay? So we have to go a step more than that. Correct? Okay. So you have 1 colon 3, right? I want 1 and 2, right? Now, same thing if you look at column. So what is the column here? Column is also 1 and 2, right? It so happens that, okay. So instead of doing 5 and 6, okay, let's do 6, 7, 10, 11. Right? So let's do this, okay, so that we don't have to give same number, right? So here, okay, it is still like 1 and 2, right, row, but column becomes 0, 1, 2, 2 and 3. So we want 2 colon, okay, for 3, I need to go 1 more than 3, right? I need to go up to 4. So when you run it, okay, now you see you get 6, 7, 10, 11. Right? And what we discussed that if you're going up to end, you don't even have to mention it, right? So if I don't mention it, you will go anyway up to the end. All right. So this is how you perform indexing. Okay, exactly the same, like what you do for other things. Only thing, you'll have a comma in between. So your left side is your rows, right side is your reference to the columns. We also have operations that you can perform, right? So you have addition, subtraction, multiplication, division. Okay, so you can perform addition, subtraction. So let's say, okay, let's generate. Okay, what I'll do here is 4 by 4, right? Let me add one more row here. So that both becomes 4 comma 4, right? And I'll probably shuffle up some numbers. 9, 4, 2, 7. So now we have L1 and X, both are 4 by 4. We can add them together, right? So I can say print adding X and L1. So we are going to add 2 matrices. So you can add 2 matrices using addition sign. So I can say X plus L1. Okay. Now when you run it, so see here, this is your X and this is your L1. So it does element to element addition, right? So the position of this element is 0, 0, right? So we start counting from 0. So this is 0, 0. This is 0, 1, 0, 2. 0 indicates row number, right? First, always we use row. Then we use column. So row, column, 0, 0, 0, 1, 0, 2, 0, 3. This 10 would be 2, 2, right? 2, 2, 2, 3, 3, 0, 3, 1, 3, 2, 3, 3. So addition will be done element by element. So 0, 0 will be added to 0, 0. 0, 1 will be added to 0, 1. 1, 0 will be added to 1, 0. So you'll see 0 plus 5, 5. 1 plus 4, 5. 2 plus 2, 4. 3 plus 3, 6. That's how it will take element from a given position and add them together. Okay. So this is how you can do it. Or you can also say, numpy dot add. Okay, numpy dot add, and then you pass x comma L1. Okay, it's going to give us same result. You can do a plus b, or you can say numpy dot add a comma b. Okay, so this is how you can perform addition of two matrices. You can subtract by putting subtract sign. So you can say subtracting x and L1. So you have x minus L1, or you can say numpy dot subtract, right? So this will do the subtraction. Similarly, you can do multiplication, division, right? So this is for multiplication, this is for division. So I'm going to say multiplying, dividing. Okay, you simply put multiplication sign, you simply put division sign, and here you can change it to np dot multiply, and you can change here also np dot divide. Okay, so now, okay, this multiplication is element multiplication. Okay, it will multiply element by element. 0 into anything is 0 only, right? That's why you got 0 here. 1 into 4, 4, 2 into 2, 4, we got 4. Right? This is really not matrix multiplication. Matrix multiplication is different. Okay, matrix multiplication is multiplying row into column. Is row into column. Okay, so what happens? I can probably show you just to revise your what do you call revise what you have done already in the matrices class. So this is how you perform matrix multiplication. So matrix multiplication, the first you have to check. You cannot perform matrix multiplication on any matrices. Okay. Now see, what we have performed here, addition, subtraction, multiplication, division, the matrices should be of same size, same shape. Now when I say same size and shape, it means number of rows and number of columns both have to be same. You can add 1, 1, you can add 4, 3. 4 rows, 3 columns can be added to a matrix of similar size, 4 rows and 3 columns. But for matrix multiplication, okay, the number of columns in the first matrix. So see, normal multiplication is does not have any particular order. That means when you do 5 into 4, it is also 20, or when you do 4 into 5 is also 20, right? The order doesn't matter. 5 into 4 or 4 into 5, both gives you same result. But when you perform matrix multiplication, okay, matrix 1 into matrix 2 is not same as matrix 2 into matrix 1. Okay, so first of all, you have to look at the number of values, number of columns in the left side matrix. That should match the number of rows in the right side matrix. So when you take square matrix means where you have same number of rows and columns. Okay, so when you take same number of rows and columns, okay, then there's no problem here because rows and columns will be same for both the matrices anyway. But if they're not, okay, then you have to make sure that the number of columns of the left side matrix should be same as the number of rows on the right side matrix. And the output matrix will be number of rows from left side and number of columns from right side. Okay. So, okay, here if you look at this diagram, this tells you how to perform matrix multiplication. So you have on left side, you have a matrix of size 2, 3, 2 rows and 3 columns. and this is 3 comma 2, 3 rows and 2 columns. Now you see, number of columns here is 3, number of rows here is 3. So they match. Only now you can perform matrix multiplication. And then the resultant would be number of rows here and number of columns here. So 2 comma 2. So see, the final result is 2 comma 2. And how you perform matrix multiplication is you multiply row into column. So the first member here is going to be, okay, left side row. So first row, okay, and first column. So 1 into 10 plus 2 into 20 plus 3 into 30. Okay, 10 plus 40 plus 90. This is going to be your 0 comma 0 element. Now 0 comma 1, 0 comma 1 indicates 0, that is first row from left side and second column from right side. So first row from left side 1, 2, 3 and second column from right side, which is 11, 21, 31. So it's going to be 1 into 11 plus 2 into 21 plus 3 into 31, which is equal to 146. Similarly, this is 1 comma 0. 1 comma 0 means second row and first column. So 4, 5, 6 into 10, 20, 30. 4 into 10 plus 5 into 20 plus 6 into 30, which is 320. And 2 comma 2 is going to be second row into second column. So 4, 5, 6 into 11, 21, 31. So 4 into 11 plus 5 into 21 plus 6 into 31, which is 335. So this is how we perform matrix multiplication. And if you want to perform matrix multiplication using Numpy, we have different way of codes. So you have to use something called as matmul. Okay, matrix multiplication is done using matmul functions. I'm going to say matrix multiplication. This is not simple multiplication. Matrix multiplication is done using, I can use here at the rate, okay, or here you can say matmul, matrix multiplication short form. Okay, so this is what you will get. Okay, so if you interchange the value, like if you do L1 into X, it's not going to be the same. So let's see here, I'll put L1 here and you put L2 next. Okay, now you run it. They are not same, right? See, 38, it is 68. Obviously, they are not same. So what we know is matrix multiplication in matrix, I mean, matrix multiplication itself, right? So matrix multiplication does follow a particular order. Okay, so A into B is not same as B into A. So these are basics of Numpy. Foundation is the Numpy is, or matrices is foundation for machine learning. We're not going to get into the in-depth of matrix multiplication, but definitely what you need to understand is your matrices or particular vectors is important. It's a foundation for most of the algorithms that we have in machine learning, whether it is simple RNN, CNN to generative AI, all of them are based on matrices. For example, okay, if we have to analyze image, now we are using mathematical model, right? We'll be using mathematical model. How can you apply a mathematical model on an image or a video? Ultimately, they need to be converted into numbers because mathematics work only on numbers, isn't it? So you have to first convert a picture or video or audio into some number format, numerical format. You're doing ChatGPT, you add some content and you get an answer. So it's a text. How do you make text go through mathematical model? Of course, you have to convert text into numbers, right? And that's where your foundation is matrices, okay? You convert a picture into a matrix format before you provide it as input to a algorithm. Okay, so I'm going to share one link. If we are not getting, our focus is from programming perspective, right? How to use machine learning model, how to perform a different analysis. But I'm going to share a link, okay, to codes on matrices, okay. And if you are interested, if you love maths, you will love that video. If you don't love maths, you will hate that video. Okay, it can become more complex. It can become complex in terms of understanding and going through it. So yeah. So but we'll stop here from the NumPy perspective. Okay, and we will be using NumPy in our analysis. Okay, in fact, a linear equation. So if you remember from your mathematics class, you'll have your problems like you would have come across problems, right? Like today my father is 3 times of my age. 10 years back he was 4 times of my age. So what is my age, right? Those are called linear problems because if you see the power of x, right? X is the variable that we want to find. Okay. So generally, if the question is what is my age, then you'll say let your age be equal to x. Okay. What is father's age? Then you'll say let father's age be x. So x is variable that you want to find. And then based on the problem statement, based on the description of the problem, you will frame your equation. That is called as linear equation. Okay, why? Because the power of x there is 1. If the power of x becomes 2, we call them a quadratic equation. So, right, you would have done quadratic equation also in your high school days, like, ax square plus bx plus c, right? If you have power 3, okay, then we call them as cubic equation, okay? Okay, and it becomes complex as you increase the power. So your linear equation, which is power 1, can be solved using using NumPy. And if you remember, there are a lot of features of matrices. You talk about rank of a matrix, you talk about determinant of a matrix, you talk about inverse of a matrix. Okay, so inverse of a matrix is a matrix which you multiply with the original matrix will result into 1. Okay, so if we have a matrix A, okay, let's say if this is a matrix, okay, the inverse of a matrix will be another matrix. So when you multiply this with that inverse, you will get all 1, 1, 1, 1, 1. That's called inverse of a matrix. Determinant is a value, is a single value that will determine the entire value of the matrices. Okay, so determinant is one single value. And if you want to find inverse, obviously, inverse of 0 is not defined, isn't it? 1 by 0 is not defined. So first you have to make sure that this matrix, okay, if you find the determinant of this matrix, it is non-zero. Okay, so you need to first find determinant, make sure that it is non-zero, only then you can perform inverse. Otherwise, you can't perform inverse. So there are some properties of matrices, and we can actually try some of these now to see how it works. So let's say, okay, yeah, let's see some example of solving matrices. But before we solve those linear equation problems, let's first see how to perform, let's say, determinant, how to perform inverse, so that when we look at the problems, we can directly get into solving the problems. Okay. So let's see this. Okay, so NumPy doesn't have all these things. NumPy has a sub package, okay, which is called linear algebra, linalg, and that has all these matrix specific formula like inverse or determinant. Okay, so to work with those things, you have to import NumPy dot linear algebra, or directly we can use it in our example. So let's say you have let's print L1 first. Okay, so I'm saying here printing L1 slash n. Oops. L1 is list, right? Did I not convert L1 into list? We call it as mat1, right? No. Mat1. Oh, so all these days, all this while we were adding list1 to it? Not right. Since again it is two-dimensional, right? It figured out that how to add, but it has to be mat 1. It has to be mat 1. You won't see any difference, okay? You will get still same value because okay, it could figure out that since it's a list, it could okay perform in the matrix format. Okay, so there is no difference as such, but here when you print it, obviously the difference is there because it's not a numpy format. Now you got into numpy format. Okay, so printing L1, which is mat1. Now to find determinant, so determinant I said is one single numeric variable. Okay, it's a float or integer variable that will represent entire matrices, whether it is 1 by 1, 2 by 2, 3 by 3, 4 by 4, 5 by 5, 10, 10 by 7 also. Need not be square matrices always. It can take any dimensions. So if you take matrix of any dimension, okay, determinant is one single number. So when I find determinant, you will get one numeric variable, okay, which is supposed to represent the entire matrices. So let's look at it. So I'm going to say determinant mat1 equal to np dot linear algebra dot determinant, and then you pass it. Okay, now you print it. Determinant mat1, it should be non-zero, only then we can perform inverse of this. 959.999, which is like 950, 960, right? 960 determinant, of course, non-zero, so we can go ahead and find inverse. So how do you find inverse? So if I say inverse of mat1 equal to np dot linear, linear algebra dot inv, and then you say mat1. So it will print another matrix, okay? Another matrix, print inv mat1, which is supposed to be inverse of the matrix 1. Okay, so this is supposed to be inverse of this matrix. Okay, how do you know? Let's perform matrix multiplication. So I'm going to say print mat1 at the rate inv mat1. Okay, so see, it is 1.00. It is okay. Now this is 0. Okay, so the elements on your main diagonal, okay, elements on your main diagonal is going to be 1, and rest of the value should be 0. So if you see, this is main diagonal. Main diagonal means 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, where row and column numbers are same. 0, 0. So this is 0, 0. Okay, this is sorry. This is again 1, 1, 2, 1, 3, 1, and rest is all 0. Okay, e power minus 17 is 0 only, right? This is called identity matrix. Okay, so identity matrix, if you find determinant of identity matrix, it is going to be 1. Determinant of identity matrix is 1. So if you want to see, you can say print of np dot linear algebra dot determinant, and then let's pass this. So this is called identity matrix, okay, where you have 1 on the main diagonal. So see, identity matrix determinant is 1. This is what I said. Okay, so when you multiply two matrices, and if it results into 1, determinant results into 1, it is you call them second matrix is called as inverse of the previous matrix. Okay, so the matrices will look like identity matrix with equal number of rows and column. Identity matrix are always square matrix. Square matrix means same number of rows and columns. Now it can be 2, 2, it can be 10, 10, but the number of rows and columns will be same. And so two property, right? One is it has to be square matrix. And second property is that the elements on the main diagonal is 1 and all the other elements are zeros. So this is how you calculate what do you call inverse or determinant of a matrix. Now the reason we were doing these two is because when we start solving our linear algebra problem, we will need this. So let's take one example and solve. Solve a linear algebra problem. Okay. Okay. So I'll again take you to Google and we'll pick up a question from Google. We will ask Google to give us a linear algebra problems. Okay. We'll pick from any website. Okay. So yep, looks hope we get a good problem. Um, okay, let's take this. So there are two equations. Okay, 0.00300x plus 59.14y equal to 59.17. And second equation is this. And we have to solve for x and y, right? So we have to solve for x and y. I think they might have solution at the end. We will first solve and then we can manually also verify, isn't it? We can substitute x and y value in the equation and the left side should be equal to right side, right? Let's solve this problem using Numpy here. So let's put the question here. Okay, 0.0. Okay. Now you see, we have to form three kinds of matrices. You have to form three matrices. First matrices is called as coefficient matrix. Okay, so first you have coefficient matrix. Okay, so I call this coefficient matrix. So coefficient matrix, you have the coefficient of the variables. How many variables you have? You have two variables here, x and y, isn't it? We have two variables, x and y here. So, we will have 2 by 2 matrix. So this is your first row. First row is 0.003, comma, 59.14. This is your first row, second member. This is our second row, first member, and 6.13. Okay, so let's say we have negative values. Why is it giving error? It shouldn't give error. Why it's giving red? -6.13, and I put minus sign here. Okay, now there is no error. Maybe some spaces or something would have got added. So this is your coefficient matrix. So we have taken just the coefficient of the variables. Now, second one is your variable matrix, which is x and y. Okay. Second one is your variable matrix, which is x and y. So, okay, first I have to convert this into matrix, right? So I'm going to say numpy into array, and this becomes our matrix. So second matrix, which we can't write because we have all variables here, is called your variable matrix, right? So variable matrix is going to be your x, comma, y. Okay, one by one. Now you have the result matrix, output matrix, okay, which gives you the result here. Now you see, this is your result. So it has two rows, and each of these rows has one column. So you put the output here. Okay, so how I read this? Okay, I'll convert this into matrix again. So how I read this is, okay, your coefficient matrix, okay, into variable matrix equal to result matrix. Okay, so here, this we know, coefficient matrix we know. We don't know variable matrix, and we know this. So what we do? Okay, we bring this side. So when you bring this side, okay, it becomes division, isn't it? Result matrix by coef matrix. Okay, so 1 by something is also inverse, isn't it? So it is like saying, so same as variable matrix equal to result. Okay, so first coefficient, we are going to get it here. So coef matrix inverse into result matrix. Okay, and you solve the right side and then you assign the values to the left side, right? When you solve this right side equation, you get xy value and that becomes your xy here variable matrix, right? So let's do this. So first of all, we have to check the determinant, because determinant is 0, then you can't perform inverse, right? So determinant coef matrix equal to your numpy dot linear algebra dot determinant, and then we will pass our coef matrix. Okay, and if determinant coef is greater than 0, right? Can it be less than 0? Also, it can be less than 0. So we just have to say not equal to 0. Negative values, right? So coef, if it is not equal to, if it is equal to 0, then you can't find a solution. Okay, if it is not equal to 0, you can find a solution. Then you will find solution equal to, so first we have to perform the inverse of coefficient matrix, right? So how do you perform inverse of coefficient matrix? You say np dot line algebra dot inverse of this, and this needs to be multiplied with your result matrix, right? Result matrix. So the solution is going to be your x equal to, let me put format string, x equal to your, so it's going to be one row, sorry, 2 rows, 1 column, right? So your x is the first, right? We said x comma y. So x will take the first value, which is going to be your solution, okay, row comma column, 0 comma 0. And your y is going to be, your solution matrix, okay, second row, first column. So 1 comma 0. Okay, let's write and see if we have got this right. Perfect. You see, your x is 10 and y is 1. And if you want to test it, we can of course test it, isn't it? So here, okay, equation 1, we are saying x has 10. So 10 into 0.003 is going to be 0.03, right? Instead of 20, you get 210 plus 59.14, right? Because y is 1. Add and tell me. So 59.14 plus 3 is 17, right? See, it matched. Now, same thing you can check for double check, right? You just want to be double sure. So 5.291 is 52.91 when you multiply with 10 minus, it is 1. So 6.13. 6.13. And how much is this? Okay, you can take the help of calculator if you want. 52.91 minus 6.13 is 46.78. Right? So see, our answer is correct, isn't it? So this is how you can use NumPy to solve linear algebra problems. With me, guys.